Hello everybody, this is going to be a talk through the May-June paper 6. This one's got two parts, A and B, remember, and what I'm trying to do is to give you some tips about the approaches that you can take to these kinds of questions. The first thing to say is that in this particular investigation, like in a lot of them, your time is about 50 minutes on section A, 50 minutes on section B. You probably won't finish it or be able to do every single part. It takes a while to get used to what is going on. You have to read a lot of information. So don't panic, take it steady. You do have quite a bit of time to do what you need to do. Start by reading the information. That's my first bit of advice. In this question, I'll read it for you. We're looking at different methods to store items in storage bins. Amara wants to use the smallest number of bins, and each bin has a limited mass that it can carry, a maximum total mass. And here's her method. For the masses of 6, 7, 4, and 2, you just basically place them in a bin until that bin can no longer hold the next mass and you move on to the next bin. So you can put a 6 in the first bin, which means that there are 4 kilograms of capacity left. The next package has got a weight of 7, so you can't put that in to the first bin. There's only 4 available there. It has to go into a second bin, which leaves 3. But then the next package, which is 4, can go into the first. And the last package, which is 2, can go into the second. And there it is. We've used 2 bins. The first one is full. It's got a 6 and a 4. The second one has got a 7 and a 2, leaving 1 mass unused, as it were. And this kind of organizing of data and thinking through what is going on is a significant way in which part A's, these investigations in IGCSE maths, work. Having had an example, you now have to do one for yourself, and you have to put the masses in the bins. Now, the 38 and the 6, they can go in the first bin. There's no problem about that here. The capacity this time is 60 kilograms. 38 and 6 is a lot less than that. It leaves 22 after you put the 38 in and 16 in total after you've put the 6 in. So the 21, which is the third mass, will not fit into the first bin. It has to go into the second bin. And then equally, the 50, which comes next, will not go into either the first or the second because at that point, they don't have the capacity for a 50 for the next package. But the second bin does have capacity for the 32, which comes next. So you can see that you're not necessarily using up bin 1, filling it up, then moving on to bin 2, filling that up. You're going bin 1, bin 2, bin 3, bin 2, bin 1. You know, you're jumping around depending on where the bins have got capacity. There are several more questions like this. The situation changes each time. This time the capacity is a lot less. It's only 20 kilograms per bin. And you can see my answers there. The 16 can't go alongside the 8 in the first one, so you have to go into the second. The 13 can't go into either the first or the second, so you have to create a third. But then the 10, the 5, and the 3 can go in the various places. The 5 can't go in the second one, it can only go in the third one. But then that leaves capacity for the 3, which is the last package to go into the second. You can see how all those sorts of things work. The only way to really kind of follow what I'm saying here is with a pencil and paper to go through it bit by bit yourself. Place the 8, place the 16, place the 13, place the 10, place the 5, place the 3. Listening to me isn't going to really do it. You have to do it for yourself. If you want to stop the video, do it for a few minutes and then switch the video back on. The second part is a different method where we put the masses in decreasing order of size before we start, and then we use the same method. So there is my work for this here. The 50, the 38, and the 32, they each need their own bin. This time the capacity is 60 kilograms per bin. But the 27, which is the fourth one, can actually fit alongside the 32. 32 and 27 is 59, so that leaves 1 kilogram unused. So just be aware there. You've got to keep your eyes and ears open, but it's completely mechanical. And none of this is solving formulas. None of this is using your graphical calculator to draw graphs. It's just thinking through what goes where. It's being logical, it's being careful, it's being organized. You're then asked what is the percentage of unused capacity in each of the bins. In part 1A, we had 5 bins with a capacity of 60, and the unused masses were 0, 7, 10, 18, and 35. So there's your calculation, 23.3%, quite a lot. In 2B, where we're using the put them in order method first, the unused capacities were 1, 1, 1, and 7, and we only needed 4 bins. That's why there was less space left, because we'd used the capacity more efficiently. And it's only 4.17, 4.16 recurring percent, a lot less. So that seems like it's an improved method. Now, if you've got 270 kilograms and you've got bins with a capacity of 80, well, just think about it. How many times does 80 go into 270? It goes 3 and a bit. So you're going to need a minimum of 3 bins, well, more than 3 bins. 3 bins will carry 240. Where are you going to put the remaining 30 kilograms? You need a 4th bin. So that's the answer is 4. Now Amara is trying to combine bins. So once again, this is an obvious example. The 10 and the 30 will make up the capacity of 40 kilograms, which we're told is the case in this example. The 21 and the 19, and then we just place the rest. Yep. We do it again. 9, 4, 7, 15, X and Y. No idea what X and Y are. Don't know if X is bigger than Y. Don't know if X is bigger than 15 or less than 4 or anything. But let's just try it. This is an example near the end of section A where you've just got to try. There's no rule, there's no method. You've just got to try and do something. Be organized, itemize what you're doing. It'll probably get you somewhere. And the big clue here, of course, it says find the value of X and the value of Y, which suggests that there's only one solution. As we'll find out, X and Y can be swapped around because it's not clear which is which, but there is only one solution. So let's place the 9 and the 4 and the 7. They can all go in the first bin. This is using method 1. There's no capacity left because we're up to 20. And then the 15 is going to have to go in the second bin. I don't know what to do with the X and the Y, so I'm just stopping there for now. Because if X is more than 5, then we'll need a third bin. Yeah? If X is less than 5, it can fit into bin 2. We'll see. Let's just stop there. Let's try method 2 on the same items. The 9, the 4, the 7, and the 15. Well, they can go like this. Remember, we're putting the biggest ones in first. So the 15 goes first. The 9 has to go in bin 2. That's second. Then the 7, well, it can't go in bin 1, so it has to go in bin 2. But we can fit the 4 into bin 1. Yeah. Again, we're now at the point where we're left with what do we do with X and Y? We don't know. So this is my suggestion. Just try some values. For X and Y, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, and just see what happens. With method 1, if we go to 1, 1, the first of my guesses, you would need 2 bins, and the same for method 2. With 1, 2, and really, it doesn't matter whether X is 1 and Y is 2 or the other way around. You can work out very quickly for yourself with a little bit of thought, because you know what's going on now, that it's 2, 2. When X is 2 and Y is 2, it's also 2, 2. Both of the methods are the same. But for 2 and 3, you get this rather odd result, that method 1 uses fewer bins. So I think that must be the answer, because it said the answer. It didn't say an answer or all answers. It just said the answer. So I think that's it. But I did go on and check, because 3, 3, X is 3, Y is 3. In that case, you require 3 bins for both method 1 and for method 2. When X is 3 and Y is 4, it's the same. You need 3 bins for method 1 and 3 bins for method 2. So the only one where you need fewer bins for method 1 or more bins for method 2 is 2, 3. And that's the final answer. So that's a hard part and a hard ending to this question. Have we done any calculations apart from the percentages? Nothing. What have we done? We've just organized our data. The final bit, it wasn't the final bit, this is the final bit where we've now got space to consider as mass. Just carries on doing exactly the same thing. Here we've got to consider the profile of the packages. And if they are 60 by 30 and they're going into a 90 by 90 box, here's the 90 by 90 box. We can fit 3 in down the left-hand side, landscape style, 30 by 60, 30 high, 60 wide on my diagram. We can fit a 4th one in on the right-hand side, portrait style, turned around the other way. And we're left with this little box at the corner here, 30 by 30, which is unused. So we can fit 4 in. And then to actually apply this method, we've got our 11 packages here, all measuring 60 by 30, so it's the same scenario. One of the tricky things about this paper 6 was that the scenario, the size and capacity of the bins kept changing as you moved from part to part. Not only was the method that you were supposed to use changing, the capacity of the bins was changing as well. So anyway, you can use method 4. You have to go back and look at your notes for that. And this is how you put them in. The 41 and the 33 can go in the first bin. The 22 cannot, so it needs a second bin. The 18 can't go in the first, so it can go alongside the 22 in the second. Likewise, the 16, what do we do with that? Oh, we can fit that into the first, and so on. But by the way, we know that 4 bins are probably necessary. So I think this 5th bin down the side here, because in this grid, they've shown a possibility, for 5 bins being used. But I don't think we're going to get to that point. So I kind of discounted that in my mind before we started. When you put them in, this is what you get. We put 3 items in the first, but there's unused capacity. There's no unused capacity in that, sorry. Because the mass is full. There's space, but no capacity in terms of mass. In the second one, there's a little bit of capacity left, but it's full in terms of space, and likewise with number 3. So there we have it. Now, if we need 3 bins, and it costs $13.50 each, sorry for jumping up and down, 3 times $13.50 is $40.50. And I think, my friends, that is the answer to that question. You've got 50 minutes for it. I have raced through it. You can do it gently and slowly to begin with yourself. And of course, every single investigation is different, so you'll never come across this one again. But what you will come across is a requirement, an investigation, where you have to gather data, write it down neatly, use logical, mathematical thinking, not necessarily any calculations of a heavy nature, just be clear thinking. Read the instructions very carefully, highlight the things that really matter, recognize that things might change from question to question or part to part, but just do your best. And you'll be surprised how many marks you can gather, even if you don't get to the end, and even if you don't get every single thing right. You can do some of the later parts, even if you make a mistake or can't do some of the earlier parts.